Good morning, this is Mr. Garcia. Welcome to my math class on YouTube. Make sure you subscribe, you like the video so we can make more of these. Every little like helps. Select the fractions that are equivalent to 3. So fractions, it's going to have a numerator and the denominator. Equivalent means equal to 3. So some of these fractions are going to be the same thing as 3. 3 is going to be a whole number. So let's get to drawing some models. So here it says there's 1. We always look at the bottom to make our fraction. It means one piece makes a whole. So I can just draw a circle, and that's one piece. But there's 3 pieces shaded. So I'm going to shade this one piece. And now I have to make another piece. Shade it. And another piece and shade it. That is 3 holes. 1, 2, 3. So that does equal 3. So I'm going to bubble an A. The second one, it says 1/3. That means the whole is split up into 3. So I'm going to make a circle and split it evenly in 3 pieces, and then one of these are shaded. And that does not equal 1 whole. It's not even 1 whole. So that is not it. 6 halves. I know this is greater than a whole because look at the top number. The top number is greater than the bottom number. So 6 halves. I am going to... There's... How many pieces are in this hole right here that I just made? It says 2 because I look at the denominator, so I'm going to split it in 2. I'm going to shade in 1, shade in 2. It says the top number, the numerator says to shade in 6. So I have to make another hole. Split it into 2. 3, 4, make another hole. Split it into 2. 5, 6. And again, I have 3 holes. 1, 2, 3. So that one's correct. Next one is 4 halves. I'm going to split it into halves again. Here's 1 half, 2 halves. Have to make another hole. 3 halves, 4 halves. That one equals 2, which is not what we're looking for. And 3/3. You should automatically recognize, by the way, that 3/3 is always going to equal 1 whole. Anytime the numerator and the denominator match, it's a whole, 1 whole. So 1, 2, 3 equals 1 whole. And that's not what we're looking for. We're looking 3 holes. So the answer to that one was A and C. Next one, each square. Each means every square represents 1 whole. So this represents 1 whole, 1 whole, 1 whole. What fraction does this model represent? Okay, so it wants us to make a fraction out of this model. First, we have to find out how many pieces are in 1 whole for the denominator. In 1 whole. And then the top number is going to be how many pieces are shaded. Okay, so let's start with the bottom number. So this says each square, this square is 1 whole, so it's this little piece is 1/4, 1/4, 1/4, 1/4. Because 4, 1, 2, 3, 4 is on the bottom, or on is how many pieces are in a whole, so that goes on the bottom or the denominator. And the top is how many pieces are shaded. Well, they're all shaded. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12/4. And that makes sense that the numerator is larger than the denominator because we have more than 1 whole. All right, third one. Oh wait, I forgot to underline the question. What fraction does this model represent? 12/4 is right here in D. And last one, number 3. Which equivalency statement is true? 2/3 is equal to 2/6. I know that's not true. I don't even have to make a model, because if they have the same amount of pieces, but this pieces are a lot smaller because there's more, then they're not going to be the same. But it's good to draw a model anyways. Okay, 2/3. Split this one into 3 pieces. 1, 2/3. That's the top one. The bottom one, I'm going to make it 2/6. Split it up into thirds first, and then split it up into 6. And 2 pieces shaded again, but these pieces are a lot smaller. So I know they are not equal. And that's what this means, equivalency. Which equivalency statements is true? So one of these is true. All right, B. These are both greater than a whole, but when the numerator is the same and the denominator is different, they're not going to be equal, just like A. So it's not B. 1/3 and 2/6, that might be. And here 1/4 and 1/2 and 4/6, that might be as well. So we're going to have to make a model for those. And make it big enough so I can have 2 holes in here. Okay, this is going to be my first hole, second hole. 1/3 up here, and I'll make 2/6 down here. Same thing for D. I'm going to do 1/2 over here and 4/6 over here. Okay, 1/3. Do that first. Here's 1/3, 2/6. And make the same lines and then split those. 1/6, 2/6. You can see that those are the same. 1/3 is equivalent to 2/6. And this is not a multi-select problem, so I'm pretty sure that C is the right answer. But just because I found the right answer doesn't mean I couldn't have made a mistake. So I'm going to do D, and if that one's right as well, then I might have made a mistake. So a 1/2, and then 4/6. Oops. One, 2, 3, 4, 5, 6. So 1/2 is going to be shaded. And 4/6. 1, 2, 3, 4. And they're not equivalent. Remember, equivalent means equal. Which statement true? There was only one of them that was actually equal, and that was C. All right, guys. I'll see you at school.